Time travelers in a block universe can't change history. So since we know no one attended Stephen Hawking's party, no one ever will. By investigating time travel, scientists are unraveling mysteries of our universe. But one question remains unanswered. Why does time seem to run in just one direction?
How is it then that we remember the past, but we don't know the future?
This seemingly obvious question turns out to have its explanation in the origin of our universe, shockingly.
The passage of time isn't set in stone. Time can be bent, slowed, even frozen. But our experience of time seems fixed. Time only flows in one direction.
There just is a direction to time. In a way, there's not a direction to space. There's no difference between up, down, left, right, forward, backward. But there's still a difference between yesterday and tomorrow.
Why does time seem to run forwards and not backwards?
So many things in our everyday life only make sense in one direction of time. You break an egg, it doesn't suddenly become an egg again. You scramble an egg, it doesn't become whole. You know, there's sort of directions of things.
This arrow of time seems to be linked to the chaos and disorder we see in our day-to-day lives. It's best explained over a coffee.
If I have a mug of coffee, there's only one way for all the little bits and pieces of the mug and the liquid in the coffee to be in this shape, and it's right here in front of me.
The mug is in what's called a highly ordered state.
But if I shove it off the table and it smashes into a million pieces, we'll never see all those pieces and the bits of liquid reassemble into the shape of the mug again.
We know the shattered mug won't reassemble itself. In scientific terms, the disorder, or entropy, of the coffee mug increases, but never decreases.
And across the universe, entropy always increases. Just like across the universe, time flows from past to future.
Everything in the universe is gradually becoming more and more disordered. But why?
We never really think about broken eggs reassembling themselves, and that actually may go all the way back to what the conditions of the Big Bang were like.
13.8 billion years ago, space-time rapidly expanded from a tiny point. In the blink of an eye, the universe was born. This marked the first moment of time.
Our current understanding of the universe is that there was a time zero. There was a moment that the universe came into being, and that is the Big Bang.
The Big Bang seems to have been an incredibly low entropy state. Everything was very ordered, very dense and very hot. So there was really nowhere for entropy to go but to increase from that state.
At time zero, the universe expanded from a highly ordered, dense speck of energy. 380,000 years later, the first atoms formed. Gradually, gas began to clump together.
Something like 200 million years later that the first stars formed, and then those formed into galaxies sometime after that.
As the universe ages and expands, it becomes more and more disordered. Galaxies move further and further apart. In trillions of years, disorder will rule. Star-building gas will run out. No new stars will form. When the last stars die, the universe will become cold and dark.
The accelerated and continual and forever expansion of our universe might make for a frankly depressing end. There will come one day when the very last star in the universe just fizzles out, and that is it.
The Big Bang may explain why time seems to flow in one direction, from the past through the present to the future, right down to the last detail.
The rise of entropy in the universe explains why you can scramble an egg from a whole egg, but it's a little harder to make a whole egg from a scrambled one.
And entropy could be a big problem for wannabe time travelers.
The arrow of time means that things get more chaotic over time. So if you were to go back in time, it breaks that law of entropy.
And is entropy, in fact, the reason why we cannot travel into the past? That is getting back to a part of the universe where the energy itself was different, the level of disorder was different. Maybe this law of entropy requires us to keep moving into the future.
The arrow of time seems to be another nail in the coffin for traveling to the past. But some scientists think there could be a workaround. Time travelers might travel to the past in the quantum realm.
Though in our macroscopic world, we don't experience time travel in both directions, it could be that the quantum realm may allow that to be possible.
And quantum time travel could change everything we know about reality. We experience the flow of time in one direction, forwards. Clock hands never reverse. Broken eggs stay broken, and people only attend a party if they're invited before it takes place. But there is a place in the universe where this arrow of time might run both ways. The subatomic realm ruled by quantum mechanics.
In quantum mechanics, we do know that the subatomic world is a very strange place.
Microscopic particles build everything we see in the universe. Quarks, leptons, and bosons. Tiny building blocks that play by their own rules. The laws of quantum mechanics. In the quantum world, subatomic particles can travel through walls or pop in and out of existence. But the laws of quantum mechanics have an even stranger property. They appear to be reversible.
In quantum mechanics, there's no difference between moving to the future and moving to the past, as far as we currently know in the laws of physics.
In the quantum realm, the arrow of time may break down. In March 2019, Russian scientists put this to the test. Using a quantum computer, they simulated an electron traveling a fraction of a second backwards in time. The team calculated that this backwards motion can spontaneously happen in the real world, though perhaps only once in the 13.8 billion year history of the universe.
On the microscopic level, the laws of physics are time reversal invariant. And so this idea of time travel actually appears in the quantum realm, at least in the mathematical calculations.
If the quantum realm's arrow of time runs forwards and backwards in the real world, quantum particles could offer a new route to Stephen Hawking's party. But it might not be a comfortable ride.
If this idea of quantum time travel is true, then you could go to Stephen Hawking's time travel party, but you'd have to do it one subatomic particle at a time.
There are more particles in the human body than grains of sand on the Earth. So safely deconstructing someone into subatomic particles and then rebuilding them isn't likely. But could quantum particles pave the way to a different kind of time travel? We send information using quantum particles every day. Electrons carry signals inside your computer, And photons carry cell phone signals into space and back. Could we encode information onto a set of particles and send them back in time, perhaps to our younger selves?
If you can just send information back in time, right, that could already make you very, very rich. Just go to next week, send back the stock market prices, and let me know. We have some stuff to talk about.
Sending information to the past to alter the present is a tantalizing idea. Perhaps we could send invites for Hawking's party back to scientists in 2009. But even if that's possible, we may never know if they got the message.
Quantum mechanics throws a monkey wrench into this and suggests that maybe the past can branch into many different futures.
If you have an interaction between two subatomic particles, and there's a probability it'll go one way and a probability it'll go another way, to us observing it, it only seems to go one way. But there's this interpretation of quantum mechanics that says they both happen. You've now created two universes. The timeline has split.
In the quantum world, sending a particle, an invitation to a party, or even a DeLorean back in time could create a new timeline. In the new timeline, Hawking's party might have been packed with partygoers, but we aren't a part of that timeline. Neither is our Stephen Hawking.
You're not time traveling back into your own universe and changing things. You're traveling to another universe at that point of time and changing things from there on forward. And it doesn't matter if you change things then, because in that universe, you don't get born later to go back in time to change things. That happened in another universe. I know this stuff is hard to understand. It's hard to explain, too. Maybe if there are an infinite number of universes, there's an alternate version of me that understands it better. I hope he has more hair.
For now, time travel is still science fiction.
So in my personal view, nothing is going to go backward in time. Particles, information, anything like that. Sometimes you hear reports of something going backward in time or being undone or whatever. It's really nothing more than a fancy version of playing a movie backward.
But perhaps someday scientists will discover a source of exotic matter to prop open a wormhole, or find a way to bend space-time back on itself.
You know, never say never, because what we consider science now would have been considered science fiction or the lunatics of a madman a century ago.
But I'm holding out a little bit of hope. Because very smart people have tried to prove that it's actually impossible and failed. You should never say never.
And along the way, we might learn how the universe works.
Time travel is definitely more science fiction than science fact. But thinking about time travel and trying to understand why it might not be possible is really interesting and can teach us a lot about the nature of our universe.
And it's also really fascinating to think about this because it forces us to take on some of the toughest unanswered questions in all of physics, and will ultimately probably lead to a deeper understanding of the very nature of reality.
To take the analogy of Alice in Wonderland, the universe really does keep leading us farther and farther down the rabbit hole.